The cryosphere is the section of the Earth which consists of ice, snow, as well as frozen land in the form of permafrost. Most of the cryosphere is geographically located in and around the North and South poles. The components of the cryosphere play an essential role in the Earth's climate. Snow and ice reflect heat from the sun, helping to regulate our planet's temperature. Due to the fact that the polar regions are some of the most sensitive to climate shifts, the cryosphere may be one of the first places where scientists are able to identify global changes in climate. The atmosphere is what envelops the outer region of the planet, consisting mostly of atmospheric gases. Had it not been for the atmosphere, all water would have been evaporated into the physical universe beyond the Earth's vicinity, also known as outer space. The atmosphere also contains heat emitted from the planet. This could have negative consequences. If there is an atmospheric imbalance, the majority of the atmosphere is made up of oxygen and nitrogen. These gases help prevent harmful gases and rays from entering our planet.
Now we will look at an interactive model depicting the water cycle. First, the water within the cryosphere is evaporated, making the cryosphere one of the starting points for the water cycle. Next, condensation occurs within the atmosphere, which turns water vapor into liquid water. Next, precipitation occurs within the atmosphere as well, which can be seen through rain. The result of all this is surface runoff, in which water goes downstream and goes back to where it came from, returning to the cryosphere to complete the cycle.
The cryosphere connects to the carbon and oxygen cycle because one way the cycle would work is that oxygen in the form of H2O and carbon in the form of CO2 evaporates from the ocean or other body of water. These chemicals dematerialize into the atmosphere, and these molecules later get absorbed by the land or the earth from plants through the process of photosynthesis. On the tips of the earth, land gets frozen solid in a phenomenon known as permafrost. When the land thaws, CO2 and H2O trapped within the permafrost gets released, completing the cycle and connecting the cryosphere and atmosphere to the carbon and oxygen cycle. There are many interactions that the two spheres have in common, one of these being sea levels. The two spheres maintain a sort of cause and effect relationship. Increase in greenhouse gases within the atmosphere consequently leads to the melting of ice within the cryosphere, which increases sea levels. In turn, the cryosphere also contributes to the atmosphere through the process of evaporation within its water-filled glaciers, which subsequently affects sea levels as well. Another interaction that these two spheres have in common is that of global temperature change. Imprisonment of greenhouse gases such as CO2 within the atmosphere causes the global temperature to rise, acting as a magnifying glass, directing the sun's heat towards the earth. This troublesome interaction affects the cryosphere as well, as it is the primary cause of global warming. With the global increase in temperature, the very existence of the cryosphere is in peril. Similar to the first interaction, a cause and effect relationship is maintained. As we can see in the graph, global temperature has been rapidly rising in the last 20 years. This is, in part due to human activity, but it is also due to the massive temperature swings concerning the cryosphere, with the cryosphere being one of the most temperature sensitive places in the world. In the next graph, we can clearly see the sea ice area had increased over the past few years and has currently reached its peak, showing no intentions of slowing down. This directly outlines the effect the atmosphere has on sea levels and how the cryosphere's very existence is threatened by it.
Now we will look at an interview explaining how human activity influences global warming and climate change within these spheres.
And when humans started changing the climate through the burning of fossil fuels. So when manufacturing was really just sort of starting off and we were really only just starting to harness fossil fuels, even those small increases in carbon dioxide in the atmosphere were enough to make a measurable impact on Earth's climate. There's some strong regional patterns in the way that this human warming signal first developed. So we see it really clearly in the tropical oceans and over the northern hemisphere continents, whereas in the southern hemisphere it took a little bit longer for that warming signal to really start.
Overall, the atmosphere and the cryosphere are very important spheres of the Earth because they play a pivotal role in maintaining Earth's many systems which are vital in sustaining life on the planet. The atmosphere is indispensable in preventing hydrogen dioxide contained within the Earth's bounds from evaporating beyond what is possible for hydrogen dioxide to be retained within the Earth's possession. The cryosphere is vital in balancing the temperature of the Earth, preventing hazardous repercussions that threaten the longevity of the Earth from occurring, such as floods and hurricanes.